All right, everyone, welcome. Today, we are going to go on a little journey. We're going to take a look at the messy, untamed world of raw data and learn how to wrangle it into a powerful, organized asset. So let's get right into it.
So, let's kick things off with a problem that probably sounds a little too familiar, right? Your data is all over the place, scattered across different files, and it's just not quite ready for any real analysis.
Instead of just throwing a bunch of commands at you, we're going to follow this data on its journey. We'll see exactly how it goes from this chaotic, scattered mess into a clean, totally structured masterpiece.
Okay, Act 1. This is all about gathering our raw materials, bringing everything together from all those different sources.
So here's a classic scenario. Check this out. We've got two different tables of data. The first one, DF1, has our employee names and what department they're in. The second one, DF2, has their names and their hire dates. The first big challenge? We've got to bring these two together.
And boom! With one simple merge command, Pandas is smart enough to combine them using that common employee column. It creates a single, complete data set. And just like that, Bob's hire date is now correctly matched up with his department. Easy as that.
Now, what's really cool is that merge is just one of the tools in the Pandas toolkit. You can think of concat as just stacking tables right on top of each other, which is super useful when they have the exact same columns. Join, on the other hand, is a bit more specialized. It merges based on the table's index, making it incredibly fast for certain operations.
And the best part is, you have total control over how you combine your data. You can specify the type of join, just like you would in SQL. This lets you decide exactly which records to keep or, which ones to toss out when the tables don't line up perfectly.
All right, so our data is all in one place now. But is it in the right shape? Well, that brings us to Act 2, forging the data into the perfect format we need for our analysis.
This brings us to a really fundamental choice we often have to make. Do we want our data in a wide format or a long format? You see, in the wide format, each employee gets their own single row. But in the long format, each test score gets its own row. The best choice here? It really depends on what kind of analysis or visualization you're planning to do down the line.
To go from that wide format to the long one, we use a function called melt. It basically takes columns like height and weight and, well, it unpivots them into two new columns, one for the variable's name and one for its value. This format is absolutely perfect for a lot of visualizations and machine learning models.
And you guessed it, to reverse the process, we use pivot. It takes all those rows from the long format and neatly arranges them back into columns. It uses the unique values from one column to create your new column headers. It's the perfect opposite of melt.
Now this is where things get really powerful. A pivot table doesn't just reshape your data, it can actually summarize it at the exact same time. So as it pivots the data from long to wide, you can tell it to calculate the sum or the average or other stats for the new cells. It's like reshaping and analyzing all in one go.
Okay, on to our final act. We're going to take our assembled, well-shaped data, and we're going to apply those finishing touches to make it totally production ready.
No matter how good your data source is, you will almost always run into missing values. It's inevitable. And Pandas has a standard way of showing this, NaN, which, as you probably know, just stands for not a number.
This special NaN value is actually incredibly useful. It acts as a consistent flag, a kind of placeholder that lets us write code to find and handle all these gaps in our data without our programs crashing.
So what do we actually do about these missing values? Well, we have three main strategies. First, we find them using a function like isNullScore. Then we can either just drop the rows with missing data completely, or, and this is often the better approach, we can fill them in with a more meaningful value, like the average of that entire column.
And it's not just missing numbers we have to deal with. We also have to handle non-numeric data. A column that has text labels, like blood types, is what we call categorical data. For a lot of analyses, we need to convert these text categories into efficient numerical codes that our computer models can actually understand.
Okay, so we've assembled, shaped, and polished our data. But what happens when you're not dealing with a few hundred rows, but a few million, or even more? Let's go over some pro tips for speed and memory.
If you want to avoid waiting hours for your code to run, or even worse, crashing your computer, you have to be smart about memory. And that really comes down to a few key principles. Choosing the right data structures, not making unnecessary copies of your data, and just generally being efficient with your computer's resources.
So here are 3 super practical techniques you can use right away. First, process those huge files in smaller pieces, or chunks. Second, always choose the most memory-efficient data types for your columns. And third, modify your data frames in place whenever you can to avoid creating all these extra copies in memory.
And here's a look at that first tip in action. Just by adding the chunk size argument when you read a file, you're telling Pandas, hey, process this in manageable pieces. This is a total lifesaver. It means you can work with files that are way, way larger than your computer's RAM.
You know, when you combine all these steps, assembling, reshaping, polishing, and optimizing, you're not just running a one-off script anymore. You are actually building a data pipeline, and that's a powerful, automated process that can reliably turn raw, messy data into a clean, analysis-ready asset time and time again.